Good morning to all. I welcome to all to this session. In today's session, we are going to discuss about the change in length of the bar due to the number of internal loads or external loads are acting on the bar. How to find the total elongation or total change in length, maybe the elongation or shrinkage. How to find? So we can discuss with the problem. You just see here one problem. Determine the change in length of the bar, and the bar is 200 mm in diameter. Young's modulus as 200 gigapascal. So this is the problem. Okay. So we have been given one bar having the segment AB, BC. Okay. AB, BC, CD. Okay. So totally three segments are there. How to find? As well as the loads. You have 100 kilonewton, 60 kilonewton, 40 kilonewton, 80 kilonewton at different points with different directions are being given, as well as the length of the segment AB, as well as BC, as well as CD. So each segment having different length. Okay, but we know that to find the change in length, the mathematical expression called PL by AE, which is derived from the Hooke's law. That is the formula we are going to use to find the change in length. But to find the change in length, load is very important. Okay, here which load, whether we are going to use which load, whether 100 kilonewton or 60 kilonewton and 40 or 80, whether we are going to take the average of all the loads, how we are going to take, that is the matter here. Okay, if a simple rod only one segment, the load is given, directly you can substitute, you can get the value. But at each and every point, different loads are there, different directions. Okay, so to find the load in each segment is the very important thing to find the change in length. To solve this problem, before we have to do one thing, whether the problem is solvable one or not. How to find, how to identify the problem is solvable one? It is nothing but the bar should be in equilibrium condition. So the net effect of forces, the sum of forces must be equal to 0. You just have 100 kilonewton, okay, 60 kilonewton, 40 kilonewton, 80 kilonewton towards right side or towards left side. Some of the loads going towards right, towards left. So we have to have a convention, sign convention. We take towards right is positive, towards left is negative. Okay. So 100, you just consider 100 plus 40, both are towards right, so 140 kilonewton, and towards left 60 kilonewton and 80 kilonewton, so it is also 140 kilonewton. So both are same, opposite to each other, the value are same, so the net effect will be equal to 0. So the given problem is under equilibrium condition, so we can further solve the problem, we can proceed. Okay, if it is not like that, the given system of force on the bar is not correct, it is not in equilibrium condition. Okay, this is the first step we have to do that. Then I told you that this PL by AE is the formula we are going to apply the mathematical expression. Okay, so first we have to segregate, okay, AB, BC, CD. So three segments we have to segregate individually. And AB, what is the total load is acting, what kind of load, whether it is acting towards right or towards left, whether it is a compressive load or tensile load. Okay, so for that you just consider this AB alone first. In AB, A is in the left side, B is in the right side. Okay, either consider A or B. First I am considering this A. A in the left side. So from this point to the left side forces only I am considering. Okay, so we have only one load, that is 100 kilonewton. Okay, so only one load 100 kilonewton acting at a point, and the sign convention, it is acting towards right side at point A. Okay, so in AB, this is the AB. Okay, in A it is 100 kilonewton towards right, I just put here. Okay, so on the other end the same load in the opposite direction, then only it is in equilibrium condition. Okay, otherwise you take point B, it is in the right side, only you take all other forces acting right side of the point B. So you have to take considering 60 kilonewton, 40 kilonewton and 80 kilonewton with the sign convention. Okay, so minus 60 plus 40 and minus 80, so totally 140 plus 40, that is a 100 kilonewton. It is in the negative value. Negative value means it is acting towards left side at B. Here you just see at B 100 kilonewton acting in the towards left side. That is correct. So you have to take either one side as well as BC. If you are going for BC, you just go for this one. You consider either B or C. Okay, I am considering B point. From B point I have 60 kilonewton and 100 kilonewton in the left side, because B is in the left side, and you sum up with the sign convention. This is 100 kilonewton, this is minus 60, so totally plus 40 kilonewton. Plus means it acts towards right side, that is the sign convention I have taken. So at B point, okay, 40 kilonewton towards right. Okay, positive value, and you need not to once again go for the other direction, simply put the same value in the opposite direction. Okay, like that you can go for CD. In CD you just go take this point D, because you have at the end point, so consider only the right side. So 80 kilonewton in the left side at D point. So at D point, this is D point, so consider at D point towards left 80 kilonewton. So this point C, same value in the opposite direction, 80 kilonewton. Now we have found out the values of load acting at each segment. Okay, now total load has been found out, AB as well as BC as well as CD, three segments. Now individually you have to find the change in length. Now use PL by AE. In each segment load is there, length is there, and cross section Young's modulus. So before going for that one, the cross section is important. So it is a uniform section, and what about the cross section? So it's not given directly, but the keyword is there. What is the keyword? 200 mm in diameter. So the cross section is nothing but it is a circular in section. It is a 200 mm. So find out the cross section area. That is nothing but pi d square by 4. So diameter you can take 200 mm. Now to solve this, unit conversion is very important. Okay, in PL by AE, okay, in PL by AE, whether all the loads are being given in terms of kilonewton, so I am taking P as kilonewton. Then length is in terms of meter I am taking. Then what about the area? Area is in meter square. It must be in meter square. Since I am applying the length in meter, area must be in meter square. And Young's modulus generally it is Newton per meter square. Since I am using load as kilonewton, Young's modulus must be substituted in kilonewton per meter square, so that this 200 gigapascal must be converted into 200 into 10 power 6 kilonewton per meter square, because giga means 10 power 9, Pascal means as it is Newton per meter square. So you convert into kilonewton, so 1000 you have to divide. Okay, so 10 power 9 divided by 10 power 3, that is 10 power 6 kilonewton per meter square. For that, this Young's modulus is 200 into 10 power 6 kilonewton per meter square. So accordingly I have to find the change in length of the bar AB, BC and CD. Okay, so I am getting a value of 3.18 into 10 power minus 6 meter, 1.91 into 10 power minus 6 meter and 5.09 into 10 power minus 6 meter correspondingly for AB, BC and CD. As well as we find in the AB, BC and CD the nature of load. Okay, the nature of load is very important. If the tensile load is applied, the length will be increasing. If the compressive load is applied, the change in length, that means the length will be reduced. Okay, so you have to take positive and negative for tensile as well as compressive loads are applied. Okay, but in our case, in all the cases A, B, B, C, C, D, everything will be compressive in nature. So you just sum up the total change in length, okay, and all the segments will be reduced. The change in length reduced in all the segments. Okay, since compressive loads in all the segments. So how to find the total change in length? The total change in length delta L equal to delta L1 plus delta L2 plus delta L3. Okay, so already found delta L1, delta L2, delta L3. We just apply the value here, get the value. Okay, so since it is being given as negative, I already told if it is compressive load applied, then the length will be decreased, so that compressive means it is to be taken as negative value. Okay, because the length is going to be reduced. So finally I am getting the value as 0.01018 mm. It is a negative value. Okay, so the total change in length, finally the length is reduced by 0.01018 mm. Okay, so this is the total change in length. Okay, so once again I am telling that first we have to identify whether the problem is solvable one or not. To find solvable problem means, the bar problem means, you have to check whether equilibrium is existing or not. Next, segregate each and every segment and find the load by using the methodology. After finding the load in each segment, apply the mathematical expression to find the change in length. It is equal to PL by AE, and appropriate unit we have to apply, get the value of change in length in each and every segment. As well as you have to consider whether tensile load or compressive load are available or not in each segment. Okay, tensile load has to be taken as positive value, compressive load has to be taken as negative value of change in length. Okay, then the total change in length you have to sum up with the sign convention. Okay, so you will get the total change in length of the bar. Okay, so that's all about this problem of bar with the number of external loads are acting. Okay, so we will see the new chapter in the next session. So thank you and all.